Your skin may not hold a grudge, but it does keep receipts, specifically molecular ones. Every hour in the sun, every walk through traffic smog, every flotation with stress-fueled insomnia ends up logged in the fine print of your skin's gene expression. These aren't just cosmetic annoyances. Ultraviolet radiation, urban pollution, and oxidative stress don't just cause surface-level issues like pigmentation or dryness. They dive into the skin's cellular command center and start rearranging the furniture. They modify your epigenome, the instruction sheet that tells your genes how to behave. And while some of that damage seems irreversible, like tattooing your face with 30 years of bad sunscreen decisions, science is now uncovering which switches can be flipped back on, and which might just need a really good apology and a serum with a PhD. At the core of this process is epigenetic aging, which isn't about your chronological age, but rather how old your cells act. Skin exposed to environmental stressors shows accelerated epigenetic aging, meaning its gene expression resembles that of older, slower, less regenerative tissue, even if you're technically still in your 30s. This is caused largely by modifications such as DNA methylation, histone alterations, and miRNA shifts, all of which turn critical genes on or off without altering the DNA sequence itself. In other words, your DNA stays the same, but it gets moodier. Let's start with the biggest villain in the room: ultraviolet radiation. UV rays penetrate skin and create reactive oxygen species, ROS, which not only damage DNA directly, but also affect the enzymes that control gene expression. Genes responsible for collagen production, skin barrier integrity, and DNA repair get dialed down, while those promoting inflammation, pigmentation, and matrix degradation, MMPs, get dialed up. This is why photoage skin looks leathery, blotchy, and suspiciously like it's been through a toaster. Now add air pollution to the mix. Particulate matter, nitrogen dioxide, and polycyclic aromatic hydrocarbons, PAHs, bind to skin and trigger a cascade of inflammatory responses. But it's not just surface irritation. They also penetrate into deeper layers, activating the aryl hydrocarbon receptor, AHR, which alters gene expression involved in detoxification and melanogenesis. That's right. Pollution doesn't just clog pores. It can epigenetically instruct your skin to become duller, more pigmented, and inflamed. It's like your city's air is teaching your genes bad habits. Oxidative stress from both internal and external sources acts like a free radical rave in your dermis. It encourages epigenetic modifications that silence repair genes and upregulate senescence-associated ones. Over time, this leads to a visible decline in elasticity, hydration, and smoothness. Imagine your fibroblasts going from jazzercise instructors to grumpy retirees. That's oxidative stress in a nutshell. But here's the plot twist. Some of this epigenetic damage is reversible. Your genes might not forget what happened, but they can be persuaded to behave like their younger selves if you give them the right nudges. Lifestyle factors, topical compounds, and even certain technologies can start reversing some of these molecular edits. Take vitamin C, for example. Far from just being a free radical sponge, it acts as a cofactor for TT enzymes, which remove methyl groups from DNA. This can reactivate silenced genes, particularly those involved in regeneration and antioxidant production. Topical vitamin C has been shown in clinical settings to restore collagen density, fade pigmentation, and improve hydration by dialing skin gene expression back toward a more youthful pattern. It's like getting your cells to reread their original job description. Retinoids are another epigenetic overachiever. They bind to nuclear receptors, RAR/RXR, and directly modulate gene transcription. They can downregulate MMPs, upregulate collagen synthesis, and normalize cell turnover, all while increasing the expression of antioxidant and repair genes. Basically, retinoids tell your skin to put down the junk food, get back to work, and stop acting like it's on vacation in 1987. And then there are peptides, especially signal peptides, that mimic natural growth factors and bind to skin cell receptors, triggering gene expression for repair, hydration, and barrier function. Some newer formulations use nanodelivery systems or liposomes to push these deeper into the skin layers, where they can be biologically active. Even ingredients like niacinamide and resveratrol have demonstrated epigenetic influence, boosting antioxidant enzyme genes, improving barrier function, and suppressing inflammatory gene expression. On the lifestyle side, sleep, exercise, and diet all play surprisingly powerful roles. Sleep enhances melatonin and growth hormone signaling, both of which help regulate DNA repair and anti-inflammatory pathways. Exercise improves blood flow and reduces methylation of stress response genes. Diets rich in polyphenol, omega-3s, and antioxidants help maintain healthy methylation patterns and support the microbiome skin axis, which has emerging influence on epigenetic regulation. Even mindfulness and stress management are linked to slower epigenetic aging, because apparently your cortisol levels are also writing memos to your skin genes. So no, you can't erase every trace of environmental damage. This isn't Photoshop for your genome. But the idea that what's done is done doesn't quite hold up anymore either. Your skin isn't just passively aging, it's actively responding, adjusting, and evolving in real time. With the right input, scientifically sound topicals, targeted nutrients, and less walking face first into pollution, you can coax your skin's gene expression back toward resilience, repair, and regeneration. In the end, your DNA might be fixed, but your epigenetics? They're negotiable. And that makes aging just a little less inevitable and a lot more fun to fight.